Okay, for today, we already got something done before we started the video, which is grading one of our old labs. But here we are now learning one last thing about how to solve logs. And I think, based on how I taught it last hour, I'm gonna teach it this way. Everybody start with this again. 5 to the x equals 8. And by now, this should become like, oh, that's easy to make into a log. Go ahead, make that into a log. The old way. And I'm going to show you a different way. Think of this like a guy who is a craftsman and he's got lots of different tools. I'm giving you another way, another tool. Yes, you can still use your old tools, but this new tool in certain situations is really handy. You know, like if you have a power nail gun, yeah, you could have done a hammer and nails, but the nail gun's just really slick. Now you solved it probably this way. You probably said log base 5 of the 8 equals x. Now what I'm about to show you is not better, it's different, and in some circumstances is a lot easier. Okay, so watch how this is different. Do you remember if you have logs on both sides that you can get rid of the logs? Do you remember? Like if we had like log base 3 of x equals log base 3 of 7, you could just pretty much say that x equals 7. You could just kind of get rid of those logs. You remember that? Okay, by the same token, you can put in a log on both sides. You can put in and take the log of both sides. Now I get to put in any log I want. A lot of times it'll say put in the natural log. You don't have to. You could use log base anything you want. I'm going to choose log base, well, I could choose log base 8 and then the right side would be nice. But I'm going to choose, what do you think? Log base 5. Because why? Because then this can go down in front and it's not in the exponent anymore. And I think you all know that log base 5 of 5 is just 1. And then 1 times x is just x. And so this whole side is just x. By using log base 5, that whole side is just x. So look, it's the same thing as the rewrite. It's log base 5 of 8. Either way, it's log base 5 of 8. So when is that ever better? Let me show you. Let's say I had 5 to the x is equal to 4 to the x plus 7. Now if I could have made these bases the same, if I could make them both into like a 5, then I could just take the powers are equal. Do you guys remember that? If it was 5 to the x equals 5 to the 3x minus 7, then you could just say that equals that. Do you remember that? If the bases were equal. But the bases aren't equal. And so I can use my new shiny tool. And I'm going to choose to use it now. And I'm going to put in log base. Well, I can't put in log base 5 on the left and log base 4 on the right. I have to pick one. I'm going to pick log base 5. I could have done either. Log base 5. And now why is this good? Because look what happened. Do you get that this side is just equal to x? You know, when the bases are the same, the answer's already there. Or another way to say it is if I move it to the front and then there's an x in the front and then that log base 5 of 5 is just a 1, so it's a 1x. So x is alone. Cool. And what's this though? This is kind of messy, Mr. Server. Yes, it is, but you can use this rule that says, here, I'm going to take this and move it down in front. So I'm going to rewrite that as x plus 7 in the front times the log base 5 of 4. Do you remember that thing called the power rule? That this can go down in the front? Okay. Then why is this good? Because now I can solve for x. There's no weird powers anymore. Now, I'm not going to lie, it's not easy to solve for x here, but I can. And I'm going to see if you can handle it. X equals, I'm distributing this out, x times log base 5 of 4 plus 7 times log base 5 of 4. You might be wondering, why did you distribute that out? Why didn't you just leave that factored like that? Because the x was trapped in there. Now, I need to get my x's all on the same side as each other. Do you get I can subtract this from both sides and then my x's will all be on the same side with each other? So now I've got x, I'm going to use a different color, I'm going to use blue, x minus x log base 5 of 4 equals 7 log base 5 of 4. Oh my gosh, it's getting worse if that's even possible. But it's almost done. So can you tell me how to solve it from here? The good part is it doesn't have weird exponents anymore. It also doesn't have fractions. If it did, I would clear the fractions. Okay, probably the 25th time that I've had 25 really smart kids sitting in the room and nobody noticed that if you can factor it, you should. There's an x here, there's an x here. That x can be factored out. Why would that help? Because now look, there's only one x. Do you get getting it down to 1x is a good thing? Because then I can just divide by something on both sides and I'm done. So I still haven't gotten it across to anybody yet. And usually it's only a couple kids by the end of the year who are like, oh, everybody's stuck. It's probably factoring. Because have you noticed how many times it's been that? Lots of times. Okay. So now I'm going to divide both sides by this. And x is alone. Now, this next part's going to be kind of confusing. You're going to be allowed to use a calculator, but this answer right here, you'd have to have this answer and the decimal that goes with it. Why? Because if we just say, use the calculator freely, that's the other big thing you can do to solve in here. Do you remember that? It's if you can factor it, you should. Clear fractions and graph both sides and see where they cross. Guess what we could have done from the very beginning to solve this question? We could have graphed both sides and saw where they crossed. And it would have been just you typing you typing incorrectly on the calculator and then seeing where they crossed. Okay, so that's not an allowable way to do it. You have to give your answer with logs like this. Otherwise, every problem becomes graph both sides, see where they cross. And I know that might be a little bit like, well, that's how I do it in the real world. Well, then you wouldn't learn anything about logs. And logs are kind of a big deal in calculus next year, so you need to know logs. Could you please, just that's happened like every other day. I get it. It's good to have water, good to be hydrated. Try not to keep it by your feet. All right, so let's see if you have learned anything about this new tool I have given you. Go to, this page will just remind you, yay, we don't have this lab anymore. We used to be able to put the M&Ms out on a paper towel and then like people would work in groups to roll dice and flip the M&Ms over and then eventually eat them. But in the day and age of COVID, it almost seems laughable that we would have kids touch something and then eat it. And sadly, that's gone the way of the dodo. Hopefully someday again, but certainly not now. All right, so get to this page. Hennon, what's that new thing I just taught you? Okay, that's true, but that's actually not the new thing. But you're right. We can make this have a common base. So what's the 4 turn into?
Squared.
Yeah, 2 squared. And then that x, somebody asked me, do those actually get multiplied then? Yes, they do. Because this is technically what's going on, is your 4 gets replaced with a parenthesis and an x squared, and then the 2 and the x are right next to each other there, and when you have a power to a power, you do multiply them. Okay, so that's 2 to the 2x equals 2 to the 3x minus 1. And once again, you could have graphed both sides and saw where they crossed. So if it was about get the answer the fastest, that'd be the fastest. It's not going to be about that. So this is the fastest non-graphing way. Just set that equal to that. If the bases are the same, you're done. Did I need any fancy log on both sides trick? No. So you just have to solve this 2x equals 3x minus 1. And if you can't solve that, sadly, you're in the wrong class at this point. All right, on to this one. Just to clarify, that is a power. 5 to the power of 5x, and this is a power. 2 to the power of x plus 7. This is where we need our fancy trick. Now, what's your gut feeling? Do you feel like we should put this as a log, or sorry, put in a log base 2 or base 5? You got to pick a side because we can't put in log 5 on one side and log base 2 on the other. We have to put in log base something on both sides. All right. I want you to talk with the kid sitting next to you, and which one do you think would be smarter? Log base 5 or log base 2? Okay, so raise your hand if you said log base 5. And there's not necessarily a right or wrong answer. Who said log base 2? All right, so there's about half and half, but a little bit more on the 5s. So we're going to say, I'll go with you on the log base 5 thing. I personally would have chosen log base 2, but this will work. Log base 5 on both sides. So everybody write that. Log base 5 of 5 to the 5x equals log base 5 of 2 to the x plus 7 power. Now, why do we do this? Why did we match those up? Because then that whole side is just really simple. That whole side turns into 5x. Could you say it's because it drops down in front? You could. Or you could say it's because we have a property that says that if these two are the same, then the answer is that. So either way, it's 5x equals. Now this is the side that's kind of gross now. But if you know some important little follow-up trick, you can fix the exponent issues. Raise your hand if you know what to do next. Neil. All right. Where?
In front of the wall.
That goes down in front. X plus 7. Now note, I'm putting it in parentheses. Otherwise, only the 7 would be times by the log base 5 of 2. And we don't want that. So I put that in parentheses. One of those things where you pre-calc kids have to really be careful with your parentheses and negatives. Okay, so now, trying to get x alone. I know some of you are going to want to divide both sides by x plus 7. And you know why that's bad? Because then I'm going to say clear the fractions. And then what are you going to do? You're going to have to just move it right back again. So that's not the right call. So we have to distribute it out. 5x equals x times log base 5 of 2 plus 7 times log base 5 of 2. Okay, now I got to get the variables on both sides. Sorry, the variable onto one side. So I'm going to take this x log base 5 of 2. I'm really technically subtracting that from both sides. I'm subtracting it here and I'm subtracting it there. Equals 7 log base 5 of 2. And from here, my favorite thing, if you can factor it, you should. X comes out, 5 minus log base 5 of 2 equals 7 log base 5 of 2. And then I divide both sides by that, and I've got it alone. I'm not dumb enough to think this is easy, but I'm curious how many of you feel confident that you can do this. If I gave you one right now, how many of you feel confident that you could do it? Okay, all right, thanks for the honesty. Most of you seemed confident, a few wavering. So what was the key? You put in logs on both sides. You picked a log that matched one of the bases. Next, this was really, really critical. When this moved down to the front, like here. Okay, that was super critical. Next, you had to multiply this out. This is where we distribute that out. Why? Because we have to get the x's together on the same side. That allowed me to move it so that this has an x in it and this has an x in it. And then I knew I could factor it out. And of course, a lot of really smart kids in the room, still nobody thinks of factoring. So I'm going to keep pounding on it, and maybe eventually you'll start thinking of factoring as the answer, because a lot of times it is. It's not like it's always the answer to everything. But when everybody's stuck, look for 3 things. Can it factor? Can I clear the fractions out? Or if I had to, could I graph both sides and see where they cross? Okay. This is a big bunch of problems that will make you practice that. Now, when you have a choice, do it the easy way. Do you guess this would be pretty easy to make this into 2 to a power? That 8 would be 2 to the what? 2 to the 3rd. Why is that good? Because then the bases are the same. So it's just 4x equals 3. Super easy. Don't make yourself put in logs unless you have to. This one also. You could make the bases be the same. Really easy. All right. This is the part where I would like you to do up through number 9. These 6 questions. These 6 right here. Do those by yourself right now. I'm going to pause for a second. And if you want to check after 1 or 2 to see if you're getting the same thing as your person next to you, that'd be cool. But do those 6 yourself. And remember that there is an answer key that you can use to look at these answers to. That's already posted. So let's just take one of them, for example, this number 9. And like, you've got a calculator. You could have just graphed it and got the answer that way. So what are we going to ask for on the test? Well, I personally would, since I can't make the bases the same, I would use putting in a log, and I'd put in a log base 3 of 3 to the 2x, because that way it just slips right out. The 2x is just free down in front. And then I have to put in a log base 3 on this side. And then my final answer is going to be divide both sides by 2. And I have x equals log base 3 of 5 over 2. And that's how I want your answer left. Now, if you have the decimal for it, great. Let's say that you get the decimal for it and you can't prove where you got the decimal from. I'm going to mark it wrong. And it can't be from the graph. Okay? All right. So basically show your work. All right. Let's move on to the next page. You'll have to do these kind too. Realistically, these will be kind of messy, but doable. What's my first law? Look and see if you can factor. What's my second one? Clear fractions. Can I clear the fraction here? Yep. As long as they're not inequalities, you can always multiply both sides by that denominator, and it will clear the fraction. Then I'll have variables on both sides. Is that good? No. We've got to get all the variables to one side. And then look for factoring, because if you can factor it, you should. Can you put in a log? Yeah, if I was going to put in any log, because there's an e in here, guess which base I would pick? Log base e, which is the same as the ln. All right, I'd like everybody to take a shot at this one, please. It is number 19. I'll pause for a second while you give that a shot. I like it. You multiplied both sides by e to the x plus 2. Is that correct?
Yes.
And then this goes away. Now I have e to the x's all over the place. What am I supposed to do with that?
I distributed the
All right. All right, so we have 100 e to the x equals 50 e to the x plus 100. Now what?
I subtracted 50 e of x.
Ooh, I like it. Subtract 50 e of x. If you had tried to put a log in on both sides, it would not have worked at this point. So I'm glad you did it this way. And now I have 50 e to the x is equal to 100. Is that what you had too?
Yep.
Now what?
And I divided both sides by 50.
Sure, that will absolutely work. And I get 100 divided by 50 is 2. I'm really close. At this point, let's use the new way. What would be the new way?
You set both sides to log base e.
I would just call it, I take the log of both sides. Take the log. Instead of set the log, take the log. Take the log of both sides. And then final answer?
Is x equals log base e of 2.
ln2. That's pretty clean. I got a decimal for that? Yeah, but that wouldn't be as nice as ln2. You know why? Because this one is exactly right. A decimal has to be rounded, and therefore it's not exact. Okay, are there any parts of this that you didn't get? Maybe you did it a different way. If you did it a different way and you got ln2, then you're good. If not, I'd love to talk about why your way didn't work. Sorry, it got really light. I can tell now that I stepped back from it. There's the answer. Okay, then, these always confuse me on show that if this is this, then that or that. I think all they're asking you to do is to factor this thing, and then the factors become these. And big surprise, if you can factor it, you should, comes up again. How do you factor this? Well, you move the 5e to the x to the other side, and then you'll be able to factor that. All right, so what's left for me to teach you? Well, there's definitely some word problems that involve logs and exponentials that we'll need to get into much deeper before we're ready to test on this stuff. But tomorrow's quiz, it will involve graphing. Let me just do one more like review of graphing with you. Let's say I asked you to graph 3 log base 2 of x minus 4. I know generally what it looks like, and this is how I would want you to think. I don't want you to think, well, I know it kind of looks like this to start with. That's what a parent log looks like. Do you remember that that's what a log looks like? If not, you got to memorize that. Then you'd make some points and graph it. So that's going to be what you'll have to do tomorrow. All right. You guys, XY chart, by the way, would be your key on that. And knowing where the asymptote is. All right, that's all I got for you for today. Have a great day.